So if we look at workbook page 85, number 1, Samira is playing a game with the spinner shown. What is the theoretical probability the pointer will land on a section labeled with the letter A on a given spin? Write as a fraction. So if you look at the spinner, there are actually 2 sections that have A's out of a total of 10. So 2 out of 10, and you can reduce that to 1/5. So 1 out of 5 chance. They said write it as a fraction, so make sure you reduce if you can. 1/5 chance that we're going to spin and get an A. So then follow up to that is part B. Predict how many times the pointer will land on a section labeled with the letter A after 300 spins. They're going to spin a lot of times here. So we've got a 1 out of 5 chance of getting an A on the spinner. If you wanted to keep it as 2 out of 10, you could. This is our total number of spins. So 1 out of 5 spins. So we're doing 300 total spins, and we're trying to figure out how many times that we would get the letter A. So at this point, we're looking for a pattern. The pattern can be up and down or across, multiplying or dividing. So one thing you can do here, going from 5 to 1 would be dividing by 5. So if you do 300 divided by 5, that would be 60. That would be 60 times out of 300. The other option, if you wanted to, you could go across. If you do 300 divided by 5 is 60. So this is multiplying by 60. And then 1 times 60 is 60. Either way is perfectly fine, whichever way you want to do that to get your answer. So we're going to go to number 4. Raquel, Richard, Honey, and Lenny equally split the price of one season ticket so they can take turns attending baseball games. If the season ticket includes 68 games, how many games should Raquel expect to attend this season? So this one, you could just say there's 4 people. We can just take 68 divided by 4, which would be 17. I think what they're wanting us to do is say there's a 1 out of 4 chance that he's going to get to go to the game. So what would that be out of 68? But we don't have to do it that way. Just divide it by 4 and you got your answer. Number 8, Camille rolls 2 number cubes together and records the sum. If she does this 180 times, how many times should she expect the sum to be 7? And they've got a table here. It's kind of like an addition chart. So basically the 2 numbers added together gives you this number. So what we can do is look at this. You can count up all these white squares if you want, or you could just say how many you've got going both directions, and then you could figure out how many different options there are here. So we've got 6 by 6. 6 times 6 is 36. There's 36 different numbers, 36 different possibilities we could have when we roll the 2 dice. And if you'll notice on that diagonal, they've got highlighted, maybe not highlighted so well of the colors in your workbook, but that's 6 out of 36 that are sums of 7. We're trying to figure out if we did this 180 times. So we can try this with 180. If it doesn't work out nicely, if this is not a nice pattern, or actually this could be a nice pattern, if it doesn't work as a nice pattern, you can reduce the 636 down to 1/6, and then that should work. So this is a nice pattern here, going from 36 to 6. That would be dividing by 6. So 180 divided by 6 would be 30. So 30 times out of 180 that she would expect to get a 7. Is it going to be exactly 30? Not necessarily, but it's probably going to be pretty close to that. We look at number 9. Based on statistics for the past several seasons, probability the best player on a basketball team makes a free throw is 8 out of 10. Probability the second best player makes a free throw is 13 out of 20. If both players attempted 140 free throws over a season, how many more free throws is the best player expected to make? So the best player, it was 8 out of 10. Now 8 out of 10 could be reduced, but we'll see if this works with what we've got. 8 out of 10, we're trying to find how many out of 140 they would make. So this has a nice pattern, is multiplying by 14. So 8 times 14, that's 112. So 112 out of 140. And then the second best shooter, it's 13 out of 20. So for this, to get from 20 to 140, we can multiply by 7. If you're not sure what to do, if you do 140 divided by 20, that'll give you that number. And so if we take this, 13 times 7 would be 91. Now we're not quite done. We figured out how many each of them would have made. The question was how many more free throws is the best player expected to make. So at that point we can take 112 minus 91, take the difference there. And that would be 21. So over the course of the season, 21 more free throws that the best player would have made than the second best free throw shooter. Number 11, the spinner at the right is divided into 8 equal sections. Part A, find the theoretical probability described below. Write your answer as a simplified fraction. So probability of a number less than 6. Less than 6. What I'll do sometimes on this, if you want, you can just circle the different options that would work, if that makes it easier. If you want to just look at them, that's fine too. So less than 6, the options would be 1, 2, 3, 4, and 5. So that's 5 out of 8 chance. And we can't reduce that, so we'll just leave it just like that. And then part B, about how many times would you expect the pointer to land on a number less than 6 if the pointer is spun 30 times. So we said 5 out of 8. And we're trying to find the number of times out of 30. And again, you guys, when you do this, if you want to put a box there, if you want to put an X or a different letter, whatever you want to do is fine. So one option here, if you want to, since these are equal to each other, we have an equation. You have the option of cross multiplying. And so that'll get you to 8x equals 150. And then you can divide by 8. So when you divide that out, you get 18.75. We can't get a certain number 0.75 times. That doesn't make sense. So that would be 19 times then. And there are other ways we could do this, even with our proportion that we had. We could find patterns with having a calculator would make that easier. We could try to look at how we can get from 8 to 30, or you could look at how you get from 8 to 5. So that would be multiplying by 3.75. And then if you multiply that 5 times 3.75. You'll get the same answer, 18.75. Another way you could do this, which actually is my preference, since the variable's in the numerator, what I would probably do, especially if I didn't have a calculator, we could just say the variable's being divided by 30, and then we could multiply by 30 on both sides. And that would be 150 over 8. And then when you divide that out, you'll get the same answer. So that's 3 ways. We could have also gone from 8 to 5. So really 4 ways we could have worked that problem out. So this gives you an idea of how to work with theoretical probability.